Hello everyone, I am Harnivius, a third year student from the Department of Artificial Intelligence and Data Science. Today, let's look at a case study, student performance prediction using linear regression. Basically, the question is simple. If we know how many hours a student studies, can we predict their exam marks? With machine learning, we can actually prove it mathematically. Before we dive in, let's refresh what machine learning is. Think of it like teaching a child multiplication. At first, you gave them examples like 2 into 3 is equal to 6, 4 into 5 is equal to 20. Later, they can solve new ones like 9 into 7 on their own. That's supervised learning, learning from examples. Machines do the same. We give them past data, they find patterns, and then they can predict new outcomes. And applications of machine learning are Netflix recommending movies, Google Maps predicting traffic, banks catching fraud, even doctors predicting diseases. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. In our case study, we are using supervised learning because we already know both the inputs and the outputs. Study hours versus marks. Now, let's talk about linear regression. Linear regression is one of the simplest supervised learning algorithms. It tries to draw the best straight line that fits the data. The equation is y is equal to mx plus c, where y is the max, x is steady hours, m is slope, and c is the intercept. Slope is like speed. If slope is equal to 9, then for every extra steady hour, marks go up by 9. Intercept is the starting point. For example, intercept is equal to 2 means even if hours is equal to 0, maybe the student scores 2 marks just for showing up. So linear regression is all about finding this line that best explains the data. So this is the problem statement. The main aim here is to see if we can predict a student's score just by knowing how many hours they study. This isn't just academic. Teachers can use it to guide students, and students can plan their study time better. And it is a very practical example of machine learning in real life. And here is our solution. We are going to use linear regression for this problem. We will train it using the data set of study hours and scores and then test it with unseen data to check how accurate it is. The idea is simple. Fit a straight line through the scatter plot and use that line's equation to predict student marks. So our solution plan is basically load and visualize the dataset, train a linear regression model, test it on new data, finally use it to predict marks for new study hours. That's the full solution approach. For this, I used a dataset with two columns, hours and scores, where hours is independent variable and scores is dependent variable. And I have created this small dataset in CSV format so that it is easy to load into Python using pandas. So this is actually good for learning. Smaller datasets are easy to visualize and understand. In real world applications, datasets are massive, lakhs or even millions of rows. But to grasp concepts, small datasets like this are perfect. So now we are going to import the libraries. I used pandas for handling data, NumPy for calculations, Matplotlib for graphs, and scikit-learn for machine learning part. Specifically, I used linear regression to train the model and train test split to split the data. Then we are going to load the data. I loaded the CSV data into the data frame using pd.readCSV function. Then I checked the first few rows with data.head function just to confirm it loaded correctly. Then we are going to visualize the data. I plotted the data on a scatter plot. On the x-axis we have study hours and on the y-axis we have scores. You can clearly see that more study hours usually mean higher scores. Each dot is one student. Notice how the dots form an upward trend. That's why linear regression fits well here. Scatter plots are the most honest visualizations. They show the raw truth. What if we had an outlier like a student studying 9 hours but scoring only 20? That would distort the line and reduce accuracy. Outliers are something ML models always have to deal with. We can just train the model on all data. That would be like memorizing past exams questions and failing in a real test. So we split the data, some for training, some for testing. In these slides, we use 80% of training data and 20% of testing data. Training helps the model learn patterns and testing checks if the model works on unseen data. Industry uses splits like 70 to 30, 80 to 20 or 90 to 10 depending on data size. Now we have created a linear regression model and trained it using the fit method. This is where the model learns the relationship between hours and scores. The model now learns slope and intercept using training data. It calculates the best fit line. Once trained, we use the model to predict scores for the test set and stored them in y underscore pred variable. And then we have plotted the regression line using matplotlib functions. And so this is the graph. The blue points are actual data and the red line is what the model predicts. The closer the blue points are to the line, the better the model. Since the dots are close to the line, it is a good fit. And to check accuracy, we calculated the mean squared error and R square scores. Lower MSC means fewer mistakes and R square closer to 1 means better fit. Both values look good for this data. So here is the output of the model. The predictor scores are quite close to the actual scores, which means the model is working well. So, we trained a linear regression model on student data, predicted marks based on study hours, evaluated it with 80 to 20 split, and found it is accurate. So, thank you.